Hello, this is Professor Wang. This is your first lesson video for this course, Math 22. This video is for lessons 1.1 through 1.6. By now, from September 3rd, you should understand how the course operates through the information provided in the September 3rd box in Canvas. If you are not familiar with the information there, you should definitely go back because it has a lot of important information in there that can answer many of your questions that you might have when you're starting off in a course. With that being said, in the announcements, I did explain that your online PDF textbook that there is a link to. Your textbook calls lessons, what I consider lessons, as questions. So if you go through the textbook, you'll see it says question 1.1. I'm calling it lesson 1.1. So that's why this page is titled the way it is. In the next page, you will see I take snippets of your online PDF textbook and I'll say question 1.1 on the next slide. So that's just a naming thing. Don't get too caught up on that. But when I refer to quizzes or assessments, I will say I'm pretty sure your first quiz is on lesson 1.1 to 1.9. That just correlates with your textbook from question 1.1 to question 1.9. So hopefully that wasn't too confusing and straightforward. Okay, your first lesson is multiplying fractions. There's many ways to show that you're multiplying fractions, but this is one way by putting two parentheses next to each other. You can use the dot symbol or the X symbol. We kind of stay away from the X symbol because it looks like the variable X, and this is Algebra 1 material. So we don't use that symbol in Algebra 1. We kind of stay away from that. So when you multiply fractions, it's very important to check a couple of things. So the first thing that you need to check for is your diagonals. So 2 and 4 are considered diagonals because they're diagonal from each other. And then, let's see if I can take that away. And then 3 and 5 are also diagonals. You also need to check your verticals. So 2 and 5 are considered verticals. And then you need to check your other vertical, which is 3 and 4. So I'm just kind of matching up directions with the problem. So those are the directions that I'm referring to as diagonals and verticals. So what you need to do first is you need to check your first diagonal, as I pointed out, was 2 and 4, and you need to reduce that fraction if possible. So 2 goes into 2 and 4, so I'm going to cross them out, and I'm going to divide it by that number. So 2 divided by 2 is 1, so that gets replaced with 1, and 4 divided by 2 is 2. Now I'm going to check my other diagonal, 3 and 5. Nothing goes into both of them or it's not reducible, so I can't do anything. Then I check 1 and 5, which is my new vertical. Nothing goes into both 1 and 5. And then the same with the other vertical, 3 and 2. So I just leave that alone. So now that I've done checking all of my directions, I can multiply across. So in my numerator, 1 times 3 is 3. In my denominator, 5 times 2 is 10. And that is my answer. So unfortunately, where people get messed up with this is they like to multiply across and they don't like to reduce within the problem. Just as a heads up, I always say this in class, what if you had a problem like this, 24 over 100 times, I don't know, 10 over 8. I'm just making this up on the spot. I definitely would not want to multiply this across because that would be, I call it insane. You would get 240 over 800, and it's just larger numbers that you don't want to deal with. So let me show you my method of checking those directions first. You can see that 8 goes into 24 and 8, so I'm going to reduce by 8. And then for 10 and 100, you're going to reduce by 10. And you get 3/10 right away. Do not multiply across and then reduce later. I think it's just ironic that I got the same answer as before. That's totally coincidence. So don't multiply across unless you have to and there's nothing you can reduce. Always check what you can reduce first. So the next example is perfect because I don't want to multiply 8 and 18 if I don't have to. So I'm going to check my diagonals, 3 and 18. We can reduce 3 and 18 by 3. And nothing reduces 5 and 8. Nothing reduces 1 and 8. Nothing reduces 5 and 6. Again, I'm checking all those directions that I was talking about before, diagonals and verticals. Now that I've reduced what I can now multiply across. 1 times 5 is 5, and 8 times 6 is 48. So before I go on to the next slide, I said this in the syllabus, which should have been read by now. I teach, I think, in a very straightforward manner, and I've been teaching for many years now, and I know what I believe is the best and easiest way to complete problems. A lot of students like to do it their own way, and as I said in the syllabus, you are more than welcome to do your own way as long as it works. Unfortunately, what happens is students use that method because that's kind of what they know, and they get into trouble when the problem changes slightly. So for example, this one, if you multiplied across, which I know a lot of people love to do, 3 times 5 is 15. I don't even know what 18 times 8 is off the top of my head. 144. And then when I look at this, I'm like, crap, I have 15 and 144. It's such a not nice number. What does this reduce by? And some students will stop. They kind of will just give up and they'll say that's the answer. But clearly we know the answer is 5 over 48. So just be careful when you use your own method. I highly recommend the methods that I show in my class. They are tried and true, and I will not steer you in the wrong direction. There are few instances where I wouldn't say another method is better than mine, but I would say equal to mine. But that's, again, my opinion. So at the end of the day, it is your choice what method you use. Okay, on to the next slide. Okay, at this point of the lesson, if we were in person, I would give these 2 problems for you to try to do on your own. So do yourselves a favor and pause the video and try these 2 problems. All right, so I'm just going to go for it. I'm going to reduce this by 7. When I reduce, so in the previous slide, I kind of showed all my work. Once I do that, I kind of show you my little shorthand. So right now, that 7 should be 1. I don't even bother writing the 1 down because it kind of gets messy. You can if you want to. I don't. So 3 and 9 reduces to 1 and 3. The numerator, 1 times 1 is 1, and 3 times 2 is 6. Okay, the next one. Thank goodness we have my method because I don't want to multiply those crazy numbers. So I'm going to reduce these 2 guys first by 5. And look what happened. There's actually a higher number that goes into both. I can reduce again. So that's going to be 1 and 2. I did that on purpose. If you look at the original problem, you can actually reduce by 15, but sometimes students don't think of the highest number that can go into both. So I wanted to show a scenario where when you reduce, you might need to reduce again. So personally, I do reduce by largest numbers when I can think about it. In this case, I would have definitely reduced by 15 to still get the 1 and 2. But I know not everyone thinks of the highest numbers, so please, after you reduce once, just do a quick check if you can reduce again. 64 and 12, I'm going to guess 4 goes into both. Well, I know 4 goes into both, I just don't know if it's the highest. 12 divided by 4 is 3, and then 64 divided by 4, I don't even know if that works. 64 divided by 4, oh, it does. 16. Okay, so that's 16. And then 16 and 3, nothing happened, so that's good to go. All right, so that's going to be 16 times 1, which is 16, and then 2 times 3, which is 6. Okay, so we had something happen here. I didn't check the verticals, and this is, again, something that I want you to be careful for. Students will tend to just look for diagonals, and they tend to skip the verticals because this problem was kind of so involved. So 16 over 6 is actually not the final answer because it can still be reduced by 2. So you have two options. You can reduce right here and start reducing by 2 to get your answer, or you can work within the problem and check out these verticals, the 2 and the 16. I'm going to reduce by 2, so that's 1 and 8. So I will get 8 times 1, which is 8, and 1 times 3 is 3. So the final answer is 8 over 3. Again, I'm totally fine if you got up to 16 over 6 and knew to reduce to 8 over 3. So just to reiterate what I said at the end of the last slide, I'm fine with your own methods, just make sure they work. Okay, the next lesson is multiplying again, but with integers. So we have 3 fractions. The first one's negative, the second one's positive, and the last one is negative. So a negative times a positive is a negative, so these two will produce a negative result. And then the negative here with this final negative will become positive. So I know my final answer should be positive, so I kind of put a positive sign there just so I don't have to look at the signs, because I feel like the signs kind of confuse students. So my first tip is to figure out your answer if it's negative or positive. So the final answer is positive, and I indicate that with a positive sign. So now basically I can kind of slash through these negative signs and ignore them. So now I'm going to reduce. I see, let's see, I got this 5 and 15. So I'm going to erase these markings because I need room to do my crossouts. So 5 and 15 reduces to 1 and 3. 7 and 21, it also reduces to 1 and 3. I have the 3's on top of each other, so they're vertical, so that becomes 1 and 1. Notice I kind of just went all over the place. I started with 5 and 15. You could have totally done the 10 and the 15, this 10 right here and this 15. You would have gotten the same answer. So when you have more than one fraction, you can go any diagonal you want first, any vertical you want first. I just personally start with my diagonals always. That's totally up to you. So the numerator is going to be 3 times 1 times 1, which is 3. And the denominator is going to be 10 times 1 times 1, which is 10. So my answer is 3 over 10, and I kind of don't even include that positive sign. That was just for me to know that the final answer is positive. All right, so for the next problem, let's see. This is going to be 2 negatives become a positive, and then this positive with this negative will become a negative. So I know my answer is going to be negative. So I'm going to cross out, erase my work, my negative work. And then I'm going to see what we have here. Okay, so I have a whole number, so I want to put that over 1 so I know that that's in the numerator and not in the denominator. And I'm going to see what I can reduce. So let's see, I have the 2 and 14. I'm going to go vertical first and get 1 and 7. And then 30 and 9, I'm going to reduce that by 3, so that's going to be 10 and 3. And then this 3 here, it's going to reduce with the 6 to 1 and 2. And I believe that's everything, yeah. So I have 2 times 1 times 10 up on top for the numerator. And then 1 times 7 times 1, which is 7. And here I'm going to include the negative sign because that's important to have negative. Okay, at this point I would ask you to pause the video and try this problem on your own, see if you can do it. I'm going to jump right into it. So the first one, I have 3 negative signs and they're being multiplied together. So the first 2 negatives will be positive, and that positive will become, that positive with the third negative will become negative. So I know my final answer is negative. Here I have to reduce. I'm going to reduce this diagonal and then reduce this diagonal. And 1 times 1 is 1, 3 times 4 is 12. Okay, the next one. This one is meant to trip you up. This second fraction is positive. When you have two negatives, they turn into a positive. So this negative with this positive is a negative, and this negative with this negative is a positive. So my final answer, I know, is positive. So let me get rid of that, and I'm just going to write a little positive sign here so I know my final answer is positive. I'm going to ignore all the signs and now just focus on the numbers. 5 and 25 reduced by 5 to get 1 and 5. Let's see, I'm going to do 2 and 8, that's going to be 1 and 4. And then 3 and 12 is going to be 1 and 4. And then I have these 4's here. I'm going to reduce those by 4, which is 1. And I think that's it. Yeah, so the numerator is 1 times 1 times 1, which is 1. And the denominator is 5 times 1 times 1, which is 5. And then again, I kind of leave that positive sign out because we just assume when there's no symbol in front, it is positive. Okay, next lesson is dividing fractions. Before I begin, I want to show you that this problem can be written like this. Because we're actually going to do that, I believe, on the next slide. And when you see, I call this a complex fraction because it looks complex. And what you do is you read it from top to bottom to figure out how to set it up. So let me show you, if the problem had started this way, this is 3/8 divided by, trying to pick a different color, 3/4. So those two things are the same format, but in this course you will see problems like that, so I just wanted to clarify that first. So when you see a complex fraction, change it to, I call this the way we know how to do a division problem. Let me get rid of the highlighting here so I can finish the problem. Okay. So what you do is when you divide fractions, you keep the first fraction and you change the division to multiplication, and then you write the reciprocal of the second fraction. Some people like to say flip. I don't really like saying flip, but I'd say reciprocal. But yes, you do flip the numerator and the denominator in non-mathematical terms, but I use reciprocal because I'm a math nerd. So now we do what we did before in lesson 1.1. I'm going to reduce by 3, get 1 and 1. Reduce by 4, get 1 and 2. And my final answer is 1/2. Okay, so the next problem, I'm going to write 15 over 16, equal sign, times 8 over 10. Sorry, I kind of wrote it much higher than I needed to. So I'm going to reduce by 8, get 1 and 2, and then reduce by 5, 2 and 3. And then this will be 3 over 4. So something that came to mind, some students might, I'm not saying you, but some students might reduce these 2's. That was not the highlighter function. Some of you might reduce those 2's, please don't. I never said to reduce horizontally or across. You only multiply across. So again, the directions is your diagonals and then your verticals. Never ever reduce across. You only multiply across. Okay, try these problems and take note. Letter B is what I was mentioning right at the start of this particular lesson. Okay, so here they included integers. I have negative divided by a positive, which I know is a negative. So my final answer is a negative. I'm going to put a negative sign kind of all the way down there because I got some work to do and I don't want to mix up a negative sign with everybody. So I'm going to write 14 over 21 times 9 over 2. Again, the benefit of figuring out if it's negative or positive, you don't even have to write the symbol until the very end of your answer. I like that. So I'm going to reduce by 2 and I'm going to reduce 2 and 14 by 2, which is 1 and 7. Reduce 9 and 21 by 3, which is 3 and 7. The 7s will reduce with each other because they're my verticals. And 1 times 3 is 3. 1 times 1 is 1. Don't forget the negative sign. And here we're going to write negative 3 as our answer because we don't write whole numbers over 1 as our final answer. All right, this next guy. So I said in the previous one that you need to rewrite this as 8 over 27. And then this guy means the divided by symbol. So I'm going to change that to the division symbol. And then I'm going to put this in parentheses because of that negative sign. All right, so let's figure out what our final answer will be. I got this positive fraction being divided by the negative fraction. Positive and a negative, when you divide, will give you a negative as your final answer. So I'm going to put a negative sign there so I don't forget. All right, so I'm going to write 8 over 27 times 15 over 16. Again, I got rid of that negative sign because I already figured out that my final answer is negative, so I can ignore it. All right, so 8 and 16 will be 1 and 2. 15 and 27 reduces by 3. That will be 5 and 9. Nothing else reduces. 1 times 5 is 5. 9 times 2 is 18. And then don't forget the negative sign because the final answer should be negative. Okay, so this next lesson is very similar to the previous one. Here we have to read from top to bottom. So I have 3 over 8 divided by 6 over 1. I always write whole numbers over 1 whenever I get the chance to, just to make the problem more approachable. All right, so the next step is 3 over 8 times 1 over 6. I'm going to reduce my diagonal, and nothing else reduces, so this is going to be 1 over 16. Again, don't reduce 8 and 2, that's horizontal. Okay, next one, I have 9 over 2 divided by 15 over 1. So that's going to be 9 over 2 times 1 over 15, reduced by 3, and that'll be 3 over 10. Okay, please try this on your own. All right, so for this, I have a negative fraction being divided by a positive number. So negative divided by positive is negative. So I'm going to write a negative symbol down here so I know that it's negative. And then I'm going to write 14 over 8 divided by 16 over 1. And that will be 14 over 8 times 1 over 16. 14 and 16 reduced by 2 to get 7 and 8. And then this is 7 over 64. Don't forget the negative sign. Okay, the next one is a negative being divided by a negative, which is a positive. So I'm going to put a positive sign down here so I know the final answer is positive. I have 10 over 4 divided by 15 over 1. And then 10 over 4 multiplies 1 over 15. Reduced by 5, I got 2 and 3. And 2, the 2 and 4 also reduces. Almost forgot that one. And this will be 1 over 6. Before I go into the next slide, very important. I feel like people might skip this. So important announcement. You must show all your work. Whether you do it my way or another way, whatever, I need to be able to see how you do it. So if you get the right answer and I can't follow your work at all, it's a 0. I believe I say that somewhere in the syllabus or in the announcements, but just as an extra precaution, if I forgot to, very important to show all your work. You will be not given credit for not showing work, and I believe it's in the instructions for your assessments as well. So please show all your work, very important. Okay, here we have a negative being divided by a negative, so this is positive, so I'm going to write a little positive symbol here. So reading from top to bottom, I have 4 divided by 6 over 7. Notice the divided by symbol is pretty large, so it's going to be the biggest one. Even if it wasn't, well, it's going to be, even if it wasn't that big, let's say it was like this, like a little tighter, you can clearly see that this is much longer than this, so this is going to be your division symbol. So that's important to know, because sometimes the fonts or whatever might be a little shorter than this long bar here. So just to help you figure out what's a division symbol and what's a fraction, the division symbol will always be longer. All right, so this is 4 over 1 times 7 over 6. I'm going to reduce by 2. I get 14 over 3. All right, next one, negative divided by negative is positive. So I have 15 over 1 divided by 3 over 4. And this is 15 over 1 times 4 over 3. I'm going to reduce, and I get 20. You can write 20 over 1 and then equals 20, but you can just go straight into 20. Okay, next you can try these 2 problems. I'm going to go right into it. You can pause. Okay, so this is a negative and then the problem. So this means that the final answer is negative no matter what. So now I'm going to do 14 over 1 divided by 7 over 3, which is 14 over 1 times 3 over 7. I'm going to reduce by 7, and I get 6 over 1, which is 6. So if you look at the previous problems, they put like a negative sign with the 14, or they put the negative sign with this fraction. That's when you figure out your final answer. If the negative sign is in front like this, that just means final answer is negative. So it's going to be negative 6, not 6. Okay? All right, so the next one, this is 1 over 1 divided by 8 over 5, which is 1 over 1 times 5 over 8. Nothing reduces. This is 5 over 8. Okay, the last lesson for this video is kind of putting everything we've done together. So I have a positive times a positive divided by a negative. So that becomes negative. So I'm going to put a negative symbol down here. If you look at this numerator, this is what I call a complex fraction. We talked about complex fraction before. This is like another version of it. In the numerator, there's a lot going on. So what I like to do is, I'm famous for side work. I'm going to figure out the numerator first. So I'm going to reduce by 2. Nothing else reduces, so this is 5 over 6. And what I'm going to do is, I'm going to replace the numerator with 5 over 6 over 8 over 9. So it's very important to do that numerator first because it has more than one step, because it has 2 steps, not 2 steps, because it has an operation to perform. So now I can proceed with my problem, 5 over 6 divided by 8 over 9, which is 5 over 6 times 9 over 8, and reduce by 3. Nothing else reduces. 15 over 16, and it's negative. So I get negative 15 over 16. All right, so splitting this down the middle, this is negative times a positive, which is negative, divided by a positive, which is still a negative. So my final answer is negative. In my side work, I'm going to figure out 4 7s times 21 over 16. 7 goes into both, 4 goes into both of these, nothing else reduces. This is my 3/4. So the numerator of the original problem will be 3/4. Okay, so now I have 3/4 divided by 9 over 8. 3 over 4 times 8 over 9. I'm going to reduce, and this is going to be negative 2/3 as my final answer. Okay, again, pause, try to do these two problems. I'm going to go right into it. Okay, so please do the side work. I think it's very important. All right, so let's see. I'm going to do my side work here. I have 2/5. Oops, I forgot to do the signs. So positive times positive is positive. Divided by a negative is negative. So final answer is negative. Okay, 2/5 times 7/3. I don't think anything can reduce. Checking. Nope. So this is 14 over 15. So this will be 14 over 15 divided by 28 over 10. All right, so 14 over 15 divided by 28 over 10 is 14 over 15 times 10 over 28. Reduced by 5. And then I'm going to reduce it by 7. Oh, no, I'm going to reduce by 14 because 14 is higher. So that would be 1 and 2. Then I'm going to reduce these 2's because they're verticals. And then I get 1 over 3, which is negative 1 over 3. Okay, moving on, my side work, let me just kind of separate here. This is going to be positive, my final answer. In my side work, I need to figure out what 1/2 times 15 over 3 is. I'm going to reduce the 15 and 3, and then this becomes 5 over 2. So I got 5 over 12 divided by 5 over 2, and I'm going to see if I can squeeze this in here. This is going to be 5 over 12 divided by 5 over 2, and that's going to be 5 over 12 times 2 over 5. Reduced by 5, reduced by 2, and this will be 1 over 6. Okay, and this concludes our video lesson.